Good evening, Mr. Ray.
Good evening. How are you doing?
I'm good, and you?
I'm fine, thanks.
Wonderful.
And everyone's popping in.
Hey, Mr. Ray.
Good evening. How you doing, Jacob?
Doing good, sir. Thank you. And yourself?
I'm doing well. Thank you very much.
Nice.
And I'm just trying to get something situated real fast. So I might look a bit distracted, but I'll be there in a moment. Excuse me.
Hello, Mr. Ray. It's William.
Good day, William.
You doing?
I'm doing well. Thank you very much. Just trying to find you guys. Okay, here it is. Unit 3. All right. And I'll be taking your attendance. Okay. And I believe we stopped somewhere around here last week.
Sorry, I'm here. I don't know if you call my name.
No, I haven't called yet. I'm about to start calling the names. It's just that I was having some issues, so I logged on late. So I'm just trying to make sure you guys optimize your time there. So I'm just trying to set up. So go ahead and try number 6 and number 7 while I take your attendance. So you might hear me call your name again if I had spoke to you earlier.
Is it on the workbook?
No, right here in front. Do you guys see number 6 and 7 is in the student book, page 51. All right. So Jacob, just going through your names again.
Sir.
George, welcome, George.
Hello, Mr. Ray. Good evening.
Good evening.
Yeah.
And Maria, welcome, Maria.
Maria Mesa?
Yeah, I got you. Got you. Good day, Justine, and good day, Dina. All right. And good evening. How you doing? All right, we got Raymond. I'm doing well, thank you. All right, Raymond, good to see you. And okay, great, Latavia. That's great. And yeah, and it's basically the same. So yeah, you might as well just respond to a private message there.
There you go. Hello, Mr. Ray.
Good day, Gennaro. All right. Let's see. Marisol, welcome again, Marisol.
Thank you, Mr. Ray.
You're welcome. And Dorcas, I've officially have you down now. And Susanna, welcome, Susanna.
Hello.
Hello. And Norma, welcome, Norma. And I'm just going a bit quick tonight. Salvador, welcome.
Hi, Mr. Ray.
And William, I already spoke for just getting your name down and just make sure. Clemente, welcome, and Adriana, welcome. I think that's everyone. Did I leave out anyone? I think I got everyone's names that's in here. It should be 16. 1, 2, 3, 4, 5, 6, 7. All right, perfect. I have everyone that's in here so far. So we're just going to get straight to it, only because November is already here, and next month we're going to be finishing up, and I will be administering your GED vouchers pretty soon. I prefer not to give out the GED vouchers until you have finished algebra, or at least a good bit of algebra. As you might, if you were in class when I went over that, algebra is about 50% of the test. Let me just get it accurately. You can find this on page 4 in Roman numerals, IV, of any book, doesn't matter which book, but algebra is about 55% of what you have to do, algebraic problem solving. And then within the 45% of the quantitative problem solving, you still have some algebra in there because you're dealing with geometry and whatnot as well. So it's a good bit of the test is geometry. And so you really want to make sure that you are adequately prepared. And someone else just came in. I let someone in and forgot. Alma. So welcome, Alma. All right, so hopefully everyone's tried in that time that I was going over your names, if you heard, number 6 and number 7 in front of you. Do we have any answers for number 6 and number 7? Remember, you can send your answers in the chat. I'll reread the questions just in case you did not know which ones we were doing. So number 6, the rectangle below has a length and width defined in terms of a variable, W, as shown. So here we see a rectangle. The length is the longer side, of course, the one that's on the bottom. And then the width, W, is on the side. So number 6 asks, which expression represents the perimeter of the rectangle? All right, I have B as an answer. So once again, which one represents the perimeter? If you've forgotten what perimeter is, or you did not know because we didn't quite go over it, that's fine, Alma. Perimeter means to add up the side. So it's the perimeter is the outside. So if you say like the perimeter of your house, the perimeter of your house is just to go, or let's say your property, you go on the edge of your property right around your house. If it was the perimeter of your house or even inside of a room, the perimeter of your room, if you know what a baseboard is, the baseboard goes on the bottom parts of the room, right around. So if you needed to know how much baseboard you needed for a room of a house, then you need to measure the outsides of the room. So that's what perimeter is. Area, number 7, number 7x is about area. Area is how much space takes up an enclosed shape. So if you're trying to find carpet for that same room, then that's area. If you're trying to find how much grass, let's say you're getting some AstroTurf or some sod for your yard, and you needed to know how much to get, you would get it in terms of area. Same with tile. All right, so I'm seeing different answers pop up. A and B seem to be the popular answers there. And then for number 7, I have an answer in letter B. So number 6, A and B's are there. And I'll work it out in a moment, just trying to give everyone a chance. Remember, try to answer. Even if you could send it in privately, that's better than nothing. Kind of gives me an idea where you are, and sometimes it allows me to review something else that you might need. All right, so 6, I also have D in there and another B, few B's. All right, let's start off with number 6. Remember, perimeter means to go around the sides. So you just simply add them up. It's literally, come on, Pam. You're literally saying the width. You're literally saying the width plus the length plus the width plus the length. All right, so if they were a 2, 2, 2, 2, you just say 2 plus 2 plus 2 plus 2. So that means we're going to add up. Now, before you can add them up, you need to see what the other sides are. So what is the value of this side here? What is that equal to?
2W minus
2W minus 3.
Right, because the opposite sides of a rectangle are equal. So that's also 2W minus 3. What is this side over here equal to?
W.
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 Right? So we have W. So that means if I want to know what the perimeter of that rectangle is, I could just add them up, and I could start here. I could say W plus 2W minus 3 plus W plus 2 minus 3. So I'm going to do that. W plus 2W minus 3 plus W plus 2W minus 3. And that's what perimeter is. So now I can add them up. And I could do that by collecting the like terms. A W, a 2W, a W, and a 2W. So how many W's is that all together?
4.
Six W's.
That's 6, yep. W plus 2W is 3W, plus 1 more W is 4W, plus 2 more gives 6W. So you could possibly guess the answer already just by that
Yeah.
first part.
So letter D,
I understand how
6W minus 6.
E would be the answer. And then I just need to put in the integers there, minus 3. So I have 2 of them, -3, and another -3 gives -6. And so 6W subtract 6, letter D, is the answer. And I believe I did get 1 D or 2 Ds. But yeah, D is the answer. Be careful of B. B is a tricky one. B is asking something else for number 6. All right, how about number 7? I see some answers in for 7. I see A, I see B, and I can't tell if these other ones were for 7 or 6 because they came around the same time. But number 7 is area. Now remember, area is different than perimeter. Now perimeter is one dimension. It just goes around, just does the sides. But area is how much space is filled in. And remember how area works is, you may remember learning about this when you learned your multiples, right? If I want to know how many spaces were in there, imagine that there's nothing here, right? I was just trying to deal with area. And imagine we don't know what those, we do know what those sides are, right? You can see clearly there are 4 units in there. Because there are 2 units here, right? 1, 2, right? So there's 2 units on the side and then 2 units on the bottom. Multiply them. 2 times 2 gives me 4. Which means if I increase the amount of boxes in here to the point where it looks pretty difficult to count them one by one, which could take some time, then there's got to be an easier way to do that. And it is. Remember, we just count how many are on the bottom. 1, 2, 3, 4, 5, 6, 7, 8, 9 on the bottom. And then 1, 2, 3, 4 on the top. And 9 times 4 is 36. So that means there are 36 individual tiles inside. And that's what we call area. Area is the amount of space that takes up. So that means if I know my dimensions, all I need is 1 length and 1 width. I don't need both of them, like in perimeter. If I know them, I can just multiply them. And that's my area. So for this one, number 7, to find the area of this rectangle, I just need to multiply my dimensions. So if that helps you out, go ahead and send your answers in. So far, I have A's and B's from number 7.
Mr. Ray, I'm lost because I know the area of a rectangle is length and width. But where do we have the 9? That is why my problem is following the example that you just put on the board.
Because that 9 was an example. That's why I scratched out those things there.
Okay.
It was just a random example. So I scratched it out so no one would think I meant B.
Let me assume W, the which is W, then the length is 2W minus 3.
Right.
Yeah. Okay.
Okay.
The area of a rectangle is supposed to be length times width, which is
right. This is
supposed to have been 2W minus 3 times W.
This means that your L is in terms of W. Remember we did that, I think, in number 1. So if I can scroll up real fast, I think it was number 1. Actually, number 3. Last week we did this for number 3. We said the length of a football field is approximately 30 yards more than its width. And so we had the length, this is W and length, but then it tells you you don't have the value of the length. You only know that it's 30 times more than the width. That's the same thing that's happened here. We don't know the length. We only know that the length is 3 less than 2 times the width. So we're writing the length in terms of W. All right, and this is why we're going over how to do the algebraic part. So number 7, what would be the area just in terms of an expression? Okay, I got some more B's there. And just for time's sake, B's are correct. For number 7, B would be the correct answer because you're simply going to multiply the dimensions. So that's W times, remember times can be written in parentheses, and because it's a quantity, we put the whole thing in parentheses. So 2W subtract 3. You don't have to distribute because your answer is already there. So your answer there is B. Any questions for number 6 and number 7? And welcome, Veronica, if you can hear me.
Yes, I can hear you. Hi.
Okay. We're on page 51 right now.
Workbook?
Student book.
Thank you. Okay. Thank you.
You're welcome.
I'm sorry I come late from work.
Oh, that's fine. I figure at 6, most people are going to, be coming in, so I'm not too harsh on that. All right, since there sounds like there are no other questions with number 6 and number 7, and just to help you, Veronica, for number 6, it was D, and for number 7, it was B.
Okay, thank you.
You're welcome. All right, number 8. Number 8 says the width of Kevin's yard. Did we do number 8? I think we did number 8. No, we didn't. The width of Kevin's yard is 10 feet more than twice the width of his garage. Which expression below describes the width of his yard if G represents the width of the garage? It's very similar to number 3 and number 7.
I think C.
Okay, here's C.
Yeah.
And what happened there? So number 8, that's what we're doing now. I hear one answer so far, C, for number 8. So go ahead, try number 8, see if you can write out the algebraic expression there. Okay, we have another one there, C. And yeah, so 2 C's. All right, some more C's. So it looks like a good bit of C's are coming in. Overwhelming. So let's go ahead and confirm that. It says the width of Kevin's yard. You needed a shape just to help you. Just to remind you that this one, there are 2 different shapes there. So one is his garage and one is, where's my pen? So one is his garage and one is his yard. So it says the width of Kevin's yard, so the width part, is 10 feet more than twice the width of his garage. So if this was his garage, then his yard, his width, is going to be 10 feet more, so plus 10, than twice the width of his garage. And so and then it said let's G be the width, so we replace that G with a W there. And so it will be 2G plus 10. So if you did get C, well done, that is correct. All right, how about number 9? Number 9 says Michael's score on a math quiz was 8 more than 1/2 of his score on his science quiz. If S is his score on the science quiz, Which expression below describes Michael's score on his math quiz? A, B, C, or D?
A.
Okay, I hear A, a loud A there. Got another A in the chat.
I want to say A, Mr. Ray.
Okay, another A. Okay, 3 or 4 A's I believe I have. 2 verbal and 1 and 2 in the chat. Just trying to see if everyone else has same votes. All right, a few more A's in. All right, let's go over this one. It says Michael's score on a math quiz was 8 more. So you know 8 more means plus, as we talked about before. So 8 more means plus, so I know it's plus 8. 8 more than 1/2 of his score on his science quiz. If S is his score on his science quiz, which expression? So here's our expression, but you'll notice that C looks like it is, but it's not. It's
Mr. Ray,
yes.
I was thinking it's D.
Well, no, it's going to be, it says 8 more than. So 8 more than would mean 8 plus.
Oh, okay.
Right? If we wrote it literally how it's written, 8 more than half his score. But we can rewrite it this way because that's normally how we write them. We write the variables first. So we have half S plus 8, and it looks like you guys understand that half S is the same as S over 2, right? Because half of S is the same as saying half of S. So well done. A is the correct answer. Does everyone understand that relationship? That S over 2 is the same as half S?
Yes.
Yes.
Okay, great. That saves a lot of time. For my morning class, I actually had to teach on that. So well done. Okay, so we've done the basics part. I did want to go over factoring. I don't recall being able to go over factoring last week. Did we do factoring last week? Does anyone remember? I remember saying I wanted to get to it, but I did not think I made it there because it's not in the book.
No, I don't think we got to, Mr. Ray.
All right.
No, I don't think you did.
Okay, it does appear though, and so we do want to know how to do factoring. All right, so basically factoring expressions is the opposite and for simple expressions is the opposite of, remember I can't really write on this left corner for some reason, but it's the opposite of the distributive property. So I'm struggling to write in there, but the distributive property is the opposite of that. So remember the distributive property is basically if I had 3 times x minus 2, I would distribute in there. If I had 5x times x, let's say negative 5x minus 3. If I had for number 3, let's say I had 6xy times 3x plus 4y. And then number 4, let's say I had.
Multiply number by number. Remember.
Right, we multiply number by number, variable with variable.
Yeah, with variable.
All right, we're gonna jump right into this. So be ready. All right, so the distributive properties says we're gonna multiply number by number, variable with variable. And as we do that, remember when you do variable by variable, you are adding the exponents using you're doing the law of exponents. So that means if you're multiplying, you're adding the exponents, you're dividing, you're subtracting, etc. So for this one here, if I was to distribute in, I'll multiply number, variable with variable. And remember, when you multiply a number with a variable, you just write them next to each other. So that's simply 3x subtract 6. You guys remember doing that?
Yes, sir.
All right, what would be the second one here? Negative 5x times x minus 3. No problem, Jacob. All right, so here you multiply this in as well. You remember variable with variable, number with number. So the negative 5 comes in.
Negative 15x. I mean,
And
negative 5.
the x's are going to turn it to a square. Right, so we get negative 5x squared.
And the positive 15.
Right, yes, and then it's going to be a positive. That negative comes in, that turns to a positive. And then 5x, the 5 times the 3 gives 15, and then the x comes in as well. So when that one's multiplied, negative 5x squared plus 15x. Any questions so far? This is stuff that we did last week. All right, I should have made more room for this, so let me erase this line. And, excuse me, draw it in a little further back. I have to shrink that other one. There we go. Some trickery there. All right, so then the next one, excuse me, what would this one be? Number 3.
$18x squared.
Right?
Y.
Well done. So we multiply number with number. So 6 times 3 is 18. As George said, x times x is x squared. And then just the y comes in. All right, how about the second part? Because you multiply into both. Every term gets multiplied. If it was 5 terms in there, all 5 would get multiplied.
I think it will be 24 y squared.
And one more thing's missing.
24 y x squared.
Well,
X y squared.
There we go. So 6 times 4 is 24. The x comes in, and y times y is y squared. And so that's what it would be if we distributed it. Okay. All right, and then the last one here, any guesses to what this would be?
Oh, minus 10x squared and
Close.
y cube.
Both of them would be cubed in the first part. So if we multiply this one in, negative 2 times 5 is indeed negative 10. The x squared times x would be x cubed, and the y times the y squared would be y cubed. All right, and how about that last part if we multiply that in?
Positive 4 x
Positive
squared.
4 x squared
y squared.
y squared. All right, and that's correct, right? The 2 negatives make a positive. The 2 times 2 is 4. The x squared comes in, and then the y is by y with the y squared. Y with the y gives us y squared. So that's what we did last week, the distributive property. But now what we want to look at is factoring. Now, like I stated, factoring, unfortunately, is not in the book as an example, but it does appear sometimes when you're doing problems, you might see them. So to do the factoring, you're just basically doing the opposite, right? Distributive property was multiplying. Remember when we did unit 1, we learned that factoring is the opposite of multiplying, it's dividing. So what you're doing is you're taking the 3x minus 6, that's example for number 1, and you're trying to divide to get back to 3 times the quantity, x minus 2. So the way that we do that is a variety of ways to do it, but I'm going to stick with the method that the first class, the morning class, seemed to like. And so for number 1, which is the same thing, we're going to turn 3x minus 6 back into 3 times x minus 2. And the way that you do that is very similar to fractions. You're going to find the greatest common factor that can go into both of those numbers, or variables, depending on the question. So what is the greatest common factor of 3 and 6?
6.
No, not 6.
3.
3. 3 is the greatest common factor.
Yeah, no mistake.
Right? And so what we want to do is kind of write it out in its factorized form. So 3 times x minus the greatest common factor, 3 times 2. And whatever repeats, that's what you factor out. So notice that the 3 is repeating in both of those terms. So that means that's the greatest common factor that we can factor out of the expression. And we write whatever repeats once on the outside of the parentheses. And whatever cannot be factored, we leave inside, which is the x minus 2. And that's exactly what we had in the beginning. So that's what we call factoring. Yes?
Why do we have that dot? I saw...
The dot is multiplication. Remember, we used the dot multiplication in algebra.
That is 3 multiplied by x.
Yes.
Minus 6
minus 3
by
times 2.
Okay, the dot represent multiplication.
Right.
Okay.
So we have to find the greatest common factor for the 3 and the 6?
For everything, variables included, but it's just in that case, it didn't have it. You see, in the bottom ones, we're going to do it with variables as well. But yes, for the first term and the second term, that's a better way to say it. Or however many terms, because sometimes you can have 3, 4, 5 terms in there. All right, any other questions?
Yeah, I had one, Mr. Ray.
Okay, go ahead.
On the last problem, number 4, on the distributive property one, I'm still lost on how to do that. Like,
okay, you're multiplying
yes,
the first term by each term inside the parentheses. And remember, the terms are separated by subtraction signs or addition signs, as we learned when we first started.
Okay.
So that means what I circled in blue, we're multiplying them. And what we learned when we were collecting like terms in the distributive property last week, we multiply the numbers together, the variables together. And when we multiply the variables together, we have to remember the laws of exponents.
Okay.
So when we multiply these two terms, the numbers are -2 and 5. And so we multiply those two together. -2 times 5 is -10. That's what you see there.
Okay.
Then we multiply x squared by x. And if you remember the laws of exponents, x squared times x, the x has an exponent of 1.
So you add that.
So you add them and they become x cubed.
X cubed, okay.
And then you multiply the next variable, which is y times y squared. And that y has a 1, so you're adding those exponents since you're multiplying, and that becomes y cubed.
Okay, I see that. Okay.
And that's the first term.
Okay.
Then you multiply to the second term. And remember, the term includes the sign in the front of it. So you have -2, you multiply numbers together, so -2 times -2 is +4.
Okay, +4. I see that. And then I go to
x
the variables.
Right. Now the variables. There's nothing to multiply x squared by. Technically, it's x to the power of 0.
So the variables are always safe to say that they're the letters, right?
Yes, the variables are always letters.
Okay.
And so x squared times basically a 1 there is just x squared.
Okay.
and then you multiply the y's together, and y times y is y squared.
Let us do number 2. Let me see.
Yes, I'm about to do number 2, but we want to really make sure everybody's got the first side, because to understand the right side, we're doing the opposite of what we're doing here. All right, so number 2, we have negative 5x squared plus 5x.
Yeah.
And we're going to do the exact same thing we did with number 1. Number 1, we were finding the greatest common factor of each term. We're going to do the same thing here. The nice part about, oh, sorry, that's a 15 in there. The nice part about this one is, I was going to say that they were both 5, but one of these is 15. All right, so to come back to this, we're going to find the greatest common factor. So what is the greatest common factor of 5 and 15?
5.
5. But we're also got to do it with the x's. And the easiest way to do that is just to factorize them by separating each of the variables. So we have, since the greatest common factor is 5, we can write negative 5 times, now what does x squared really mean? What is x squared?
Times x.
Multiplying x by
x.
So then I can write x times x.
Wonderful.
And I'm going to add that to my factorized form of 15. And what was the greatest common factor of 15? And 5.
3 times 5.
Right, so I'm going to put 5. I'm going to put it in this order. It just makes it easier to see. So I'll put the greatest common factor first. You don't really have to, but 5 times 3. And then there's just 1x. And I'm going to have to write this underneath to really fit it. So now what you're looking for is what's in common. If anything is in common, that is what's being factored out. And what's being factored out is what we write in the front of the quantity. So when we look at each one, we see there are two 5s basically. And because of that, this could throw you off a bit. Let's see, how am I going to do this? So hopefully this don't throw you off, but this plus, because there's a negative here, we want to rewrite this so that this is a negative, this 5. And the only way to rewrite that so that it's a negative, but it still satisfies this positive, is to remember that a positive is the same as a minus minus. And so I can replace the plus sign with a minus minus sign, which is really a plus. Right, so you see that math is a lot of logic. Logic just means being able to realize the equality or equivalences between things. It's a little bit more than that, but that's the basics of logic, is being able to use something that you know to prove something that you didn't know. All right, so I'm rewriting that plus sign with a minus minus. Now what this does, it allows me to identify those two negative 5s to be the exact same thing. And when I do that, I can write the negative 5s on the outside. And then I see those are in common. I could cross them out if it helps. And I can look at the 3. There's no other 3 in common, so I skip that. How many x's do we have in common?
3.
Well, remember they're actually separated. This is the separation line.
2.
Okay, 2.
Not 2. How many are on the right side?
1.
1. So I only have 1 in common. This one and that one that I crossed out. And what's in common, I write on the outside. So that leaves me with what's inside. What's left, I have, that 5 is canceled. We have x on the inside. Remember, we're going to use the the minus sign that we just created there. Minus 3. And that's what we had before. So we factored it out. So I'm going to do that one over just so that you can see it, and hopefully you understand the plus thing, just so that you can see it a little bit clearer. But hopefully you understood that. So I'm going to start it from scratch so you see it in its fluidity. All right, so we have the greatest common factor is 5. So I write it as -5 times, I'm factorizing everything, x squared is x times x. Now, technically, I could write a plus sign because 15 is 5 times 3, but I want a negative, right? I want both of those to be negatives. So instead of writing a plus, I can write subtract -5. And that is still the same thing. That's still the same as saying plus 5. But now I have it as a -5 times 3 times x. And now I just need to see what's in common. -5 is in common, the -5 is in common. That could go on the outside. The x is in common, the x is in common. That could go on the outside. Nothing else is in common, so I write what's left. The x, the subtraction sign, and the 3. And now it's factorized.
So you cross out the commons and keep what's left.
Right. I didn't do it up top because it's easier to see, but basically cross out what was in common, that comes on the outside, and then write what's left. X minus 2. What's left here is x minus 3. All right, any questions about that?
Mr. Ray, is it okay if
Can we get homework on that, Mr. Ray?
Yes, I'm gonna send you a worksheet on that.
That would help.
Any other questions on this?
Can we do another one similar to that?
Well, let's finish off this and then we'll do something. It's only because I really want to try to get through this part here. And you'll see that it's basically the same concept. And the reason why I don't want to just focus on the similarity of that one is because you never know what type of question you might get. The key is you want to understand how to do it, no matter what type of problem they give you. All right, so number 3 is going to be the same one that's on the left. Remember, we're just doing the opposite. These are opposites of each other. So number 3 was the solution that we got was 18x squared y plus 24xy squared. And so when we simplify this, when we factorize it, we should get the original before we distribute it. Right? We should get this. That's what we're trying to get. All right, so let's go about doing this. First of all, we want to know what the greatest common factor of the numbers are. So what is the greatest common factor of 18 and 24?
6.
6, right? So we're going to write those in terms of 6. And there's no negatives, so it should be much easier. So we have 6 times what gives me 18?
3.
So 6 times 3. And then x squared can be rewritten as what?
X
times x.
X times x. And then there's a y there. So everything's in a factorized form. Then I can add. Remember, we're using our greatest common factor of 6. So 6 times what gives me 24?
4.
4. So 6 times 4 times x. I'm gonna try to fit this in here times y times 1 more y. Hopefully you can make that out.
Looks like a G.
Yeah, I was scared to try to rewrite it because
yeah, it's cool. I know it's a lot.
It's a touch screen, so if I go too close to the side, a menu pops up. So I'm gonna try to get it in there. Times x times y. And just take it my word for it. That's a y times y. So that's 6 times 4 times x times y times y. All right, so now that we've done that, we just want to take out what's in common. Remember, what's in common, we're going to write that on the outside. So starting at the 6, what do we have in common? 6 and a 6. So that goes on the outside. The 3 and the 4 are not in common, so I skip that. Do I have x's that are in common, and how many?
1.
2.
1. Only one x, right? From each side of the addition sign. So that x and that x. So that's 1, and that comes on the outside. So we can skip the x's. Do we have any y's in common?
Yeah, 1.
Yeah, 1 y.
Right, so we can cancel that out. And then we can open the parentheses and we write what's left over. And what's left over on the First part, 3x plus
4y.
y. And there we go. It's in its factorized form. We have factorized it back into its original form.
Oh.
That one was easy to
Okay,
understand.
that one made a little more sense, yeah.
That
But that's
made
because
sense.
I didn't have the subtraction sign. I'm pretty sure the number 1 and 3 were easy. Negatives always throw people off. And that's why you might hear me every class, I say, go back and study integers. Because the negatives, you will see it through everything in Unit 1. Every little section is repeated in algebra. All right, number 4. Number 4, the final answer that we had was negative 10 x cubed. This one has negatives, so just be mindful of that. Y cubed plus 4x squared y squared. We want to factor that, and we want it to equal what we had over here. And remember, in order to do that, you want to make sure you choose the greatest common factor. So what is the greatest common factor between 10 and 4?
2.
2. But be careful here, there's a negative there, which means we're going to have to compensate it right here, just like we did with number 2. All right, so we're going to write out the greatest common factors. I might have to write this one below because it's much longer. So hopefully I can fit this all in. This is going to be equal to negative 2 times what gives me 10?
5.
So that's negative 2 times 5. X cubed can be rewritten as what?
X times X times X.
X times X times X. And this would be, I need a lot of room for this one. And Y cubed can be rewritten as?
Y times Y times Y.
Y times Y times Y. Now, the more you practice this, the easier it gets. After a while, you can see it without doing this. Like when I factorize, I don't write this out. I just bring it out. And that normally comes with lots of practice. All right, so because there's a negative 2, I need my 4 to be written in terms of a negative 2. So what can I do to replace that plus sign?
Minus negative.
Minus negative 2. And now that is still the same as positive, but allows me to write it as a common factor. So just simply by doing that minus minus, something we've learned like in the third lesson. So I have minus 2, and negative 2 times what? Well, 2 times what gives me 4?
2.
2
times 2. And then I need more space. Hopefully I can fit this. Times 2.
X times X.
And then X times X, that's correct.
X.
And then
Y times Y.
Y times Y, I think I got it in there. Perfect.
Wait.
All right, so now we can just cancel out what's in common. And whatever's in common, we're going to write on the outside. So
X.
what's in common? Start with
The negative 2s.
Negative 2s are in common, so on the outside, negative 2. We can skip 5 and 2, the next numbers. How about X's? How many X's are in common?
2.
2. 1, 2, 1, 2. So 2 go on the outside. But we know that X times X is X squared, so I'm just going to write it as X squared. Then we can go to the Y's. How many Y's are in common there?
2.
Should we have 2? Hold on. Oh, I put a Y cubed. Hold on, 2 Y cubed. That should have been Y squared. Shouldn't have 3. Hold on.
Yeah.
Oh, okay, I see why. I didn't write this other one out it's going to be a little bit different than the other one. So that's right. So yeah, so Y squared, I was trying to make it match the other one, but the other one's not written fully correct. So Y squared on the outside, that was correct. And now I just need to write what's left over. So what's left over?
Y.
5.
Minus 5.
No, just positive 5. That's supposed to be multiplication. So 5.
Times Y.
Well, there's an X still there. I don't know if you guys can see it. I'll do it
Oh, yeah.
again.
Yeah.
Bigger
So
font.
5x.
5x, 1y there,
Uh-huh.
and then a minus sign, a 2.
Just 2.
And
That's it.
just 2, yeah. I can't cancel this out. I'm not sure if anyone sees. Okay, there we go. And just a 2. And that's its completely factorized form.
Mr. Ray, let me ask a question. Let me ask
Yes.
something. In the terms of a common factor, where do we have the 2 square, the 2x square? Because I see there are 3x. 1, 2, 3. In the other way around, we have 2. So when we cancel, it will be 1. Where do we have the square?
The 1x is inside the brackets, inside the parentheses, and the other 2 on the outside. Do you see that? I know it's tiny, but
5xy squared.
the
Okay,
X,
okay. Yeah.
if you try to multiply it in again, you'll see it.
Okay. 10x cubed. Then 4x
Right. You multiplied it in, you see it. And then y squared times that y would give y cubed. Now it's a little bit different than this because how I wrote the first one, but technically this can factor out, these y's can factor out. So like I said, it wasn't complete. Normally when a distributive property is given to you, it's already completely factored. I didn't write that out right. So, but that's the correct answer. So if you were to multiply it out, you see you still get the same answer as this one.
Okay.
All right, so those were complicated ones. If you could do these, you should be able to handle anything they throw at you. Now, like I said, sometimes they might have 3 or 4 terms. I don't think they will. They seem to keep things, for the most part, basic. But basically, if you could do this from what I've seen from the GD, you should be fine with factoring. All right, any specific questions to what we've just done here? Any specific questions? All right, if not, I'm going to switch this around and see if I could get my remind up. I've already sent, like I said, you guys have almost caught up the other class. So they're only like a day now or so ahead of you. And I just sent it to them, so I'm going to open up their worksheet and then I'm going to resend it to you guys. Factoring. So I'll send the distributive property first. So you're going to see it pop up in your remind. Okay, that's the first one. That's just the distributive property. That's the first part. Just remembering how to multiply that in. Okay, and then the second one that's about to come is the one on factoring. And then, okay, factoring. I might as well send this now. Can I drag this? See if this works. All right, and then we're going to try to get to this one today. So you should see 3 things there, and I'm going to reshare. So hopefully everybody has this. I'm about to close this out. All right, no rebuttals. Okay, so I'm going to open up the factoring. This is what I just sent you guys. Pretty straightforward. It's a more easy one. but just to show you how it works in a simpler format so you can feel confident again. But remember to practice those other ones. If you were to factor these, starting with the initial one, let's start with number 11. What is the greatest common factor between 8 and 72? Not all at once.
9.
No,
Not
close.
9.
8.
8. Right? So we can rewrite this simply as 8 times B plus 8 times 9.
9.
All right, and so when you factorize that, the 8s are in common, so they could come on the outside, and then B plus 9. And you're done. These are pretty straightforward, like I said. So this will give you that practice of just mastering the basic concept of factorizing expressions. All right, how about number 22? What is the greatest common factor of 9x, 9 and 18?
9.
9. So we have 9 times x minus 9 times what?
Mr. Ray, I think it will be 3.
9 times 2.
9
It's
times
3.
2.
9 times 2. You want to choose the greatest common factor, not just a common factor, but the greatest. And so the 9s are in common. So the 9 comes to the outside, and 9 times the quantity x subtract 2.
How'd you get the 2?
Because 9 times 2 is 18.
Oh.
Okay, so hopefully you're starting to see it. Go ahead and try number, man, this thing's irritating. Why is that in the way? Try number 1.
Hey.
3.
Number 1 is 3x
3x plus
5.
There you go, 3x plus 5. And after a while, you start to see you can do this
5
mostly in your head.
times 3.
But you have 3 times x. Remember, this doesn't really come up to well.
Yeah.
So 3 times x plus 3 times 5. 3's are the same, so they can come out, and you're left with x plus 5. So that's the factorized form. Okay, try number 12. What would 12 be?
Seven times C minus
5 times 7.
All right, you want to say quantity. So 7 times the quantity, C minus 5. So that's correct. So 7 times C minus 7 times 5. The greatest common factor is 7 there. The 7s can come out on the outside, and you're left with C subtract 5. So 7 times the quantity, C subtract 5. All right, is that making sense? Does that help?
A little bit.
Yes.
All right, let's,
I'm getting there. I'm getting there.
Okay, let's try a few more. And then we're going to have to move on. Let's try number 16, because I don't want to do them all. I want you guys to practice them. Remember, the answers, the answers are at the bottom, so you can always check once you're done. Let's try number 16, and then number 27, and that's where we're going to stop. So number 16 and number 27. So once you get it, send your answer in the chat. I want to see, hopefully everyone should be sending answers in there.
Okay.
All right, 2 answers in. And since you guys sent those privately, everyone who sent it in so far, those are correct. And go ahead and try 27 if you finished number 16. All right, Adriana, that's correct as well. And Dorcas. All right, Dina, that's correct. Veronica, that's correct. Justine, both of those are correct. Gennaro. Just need those parentheses there.
Oh.
So like that.
Okay, let me rewrite that.
Veronica, that's correct. Dina, that's correct.
How's that?
Yeah, there we go. Well done.
All right. We'll work on this next one.
All right, Salvador, that's all right. That's correct. For the last one there. All right, I'm gonna start the first one. I got a good bit of answers in, and so far everyone's been correct. So these are, of course, very straightforward, but you still want to practice those more challenging ones. I'm gonna try to find another worksheet on this.
Okay, let me see. I'm seeing the
All right, so we have the greatest common factor there is 9. So we have 9 times C minus 9 times 7. So the 9s come out because they're the same. You're left with C subtract 7. And you'll start to see, if you practice through this worksheet, you start to see after a while you can just do this in your head. And then you'll start to see you could do even the more complicated ones. Because like the ones I gave you, like I said, I do those in my head as well. But it just comes with practice. It's not that any person's better than anyone. I just have more time to practice than you. And that's all you want to keep in mind. You can do anything you put your mind to. All right, 7z subtract 28. Well, the greatest common factor there is 7. So 7. And then I was going to do it a different way, but I'm trying to stick to one method, sorry. So we have 7 times z times 7 times 4. And those 7s are the same, so the 7s come on the outside, z subtract 4. And most of you got that correct, if not everyone. So well done. Those are all correct answers. And that's the basics. So the rest of them you do want to practice and try. So what I'm going to do now is to go ahead and see if I can find one more sheet. So I'm going to stop sharing for now. And just put it back to this. We are about to move on to equations. I just want to see if I can find a worksheet that has the popular, not the popular, sorry, the more challenging ones. So that's what I'm doing right now. So I'm going to keep looking for those, but I'm going to reshare the screen and just kind of review this because I don't want to spend all night looking for this thing. All right, so where was I? Where's that? What is open? You guys see the pages, right? The book?
Yes.
Okay, so we're going to look at equations, and I'm just going to reshare one more time to here. So basically, it has a similar thing as what you see in the book, but I just really want to make sure you guys know the difference. So here's the basic difference. An equation, as what you see in the book, is a mathematical statement that shows an algebraic expression on each side of an equal sign. But what you want to see here and definitely get and gather is the difference. Okay, great, Salvador. The difference between expression and equation. So you see there on the left is an expression, just x plus 3. But on the right is an equation, x plus 3 equals to 5. On the left, 2x subtract 5 is an expression. And then on the right is the equation, 2x subtract 5 equals to negative 4x. On the left, we have 3 times the quantity x plus 7, subtract 8. And on the right, we have that equal to 9x subtract 4. Now, when you see it equal, and sometimes it's confusing people, but when you see it equal to a completely different thing, we call that an equation. Now, for the most part, I try not to use equal signs when I'm factoring, but it's just when you run out of space, we end up doing it. Equal signs can also be used as equivalency. So for example, we say this is equivalent to 2 times x minus 4. But don't think that's an equation. You don't want to solve for this, because if you do, you're going to get confused by your answer. So when you see people do this, this is a little bit different. When you see things that are, we call these progressions of equivalency. Most times, when I have a lot of space, you won't see me do this at all. You would see me write it underneath. So I'll say 2x subtract 8 is equal to 2 factorizing 2 times the quantity x minus 4. And I'll write it underneath. The only time I write it on the side is if I don't have much space underneath. But it does not mean that this is an equation. And I know that can be a little bit confusing at first, but just keep that in mind. When you see people just doing these progressions, they're just saying that this is the same as this, which is the same as that. Sometimes people use arrows to help to alleviate the confusion. Or we use the 3 equal signs to say they're equivalent. But in its pure sense, when you see an expression equal to something totally different, we are talking specifically about an equation, right? An expression equal to a term that is not the same equation. An expression equal to a completely different expression, that's an equation. And with equations, you can solve the equation, whereas expressions, you normally simplify or evaluate. That's typically what you would see for an expression. They might say evaluate or simplify. Whereas with an equation, it would say simplify and then solve. Then solve, right? So those are typically the language that you see. With an expression, you find a value. Whereas this one here, you solve for a value, right? So sometimes you can tell what you're dealing with just by the terminology, the language that's being used. So you hear the word solve, solution, stuff like that, is talking about an equation. All right, so that's what we're going to be doing, but I forgot to go over order of operations with you. So does everyone at least have this down?
Mr. Ray, I've not got them in my reminder. I'm still searching for my reminder. You said send them through.
Say that one more time.
You talk of sending some information through our reminder. Is that so?
This
that
right
you
here?
send some, you will send some information to our reminder.
Yeah, I sent it. You didn't get it?
I didn't get this.
I don't know what to say there.
You see, all this while I've been silent just because. What is the class code?
You not got remind?
Yeah, I had a remind, but it tells me of the class code, so I don't know why.
Oh, you must have got kicked out somehow. All right, let me get that for you real fast. All right, so I'm just gonna minimize this real fast and see if I can get out of here. Okay, so I'm just clearing this, and this is, if you're done, hopefully you're done. Yeah, it's just the same thing. What you want to write out is the order of operations. So this is what you want to write out, and I'm just going to get a code there for, oops, a code for George. You guys still see it?
Still, I've still not succeed. I'm still searching.
Mr. Ray, I have the code right here if you need it.
Sure, yes, it'll save me time.
It says at.
Okay, hold on, I'm gonna type it to George. Actually, I'll write it on the screen. That'd possibly be the
Or do you want me to just put it in the chat for him?
George, you know how to check the chat?
I'm still searching, sir. I've not got it.
Okay, no, you can say it. So what is it? At?
It's at MATHDOU.
Okay, thank you so much. George is right on the screen.
Okay.
Yeah.
Okay, let me put it. Okay.
All right. Does everyone else, do you guys have the order of operations?
Yes.
You know?
Yes, we have it.
Okay, so just to kind of recap over this, you might even remember one of the terminologies previously. But what you see here, some of you might have learned it as PEMDAS. Might ring a bell. Normally you see a D and an S there. I choose to take it out because it can cause confusion. And you might have even seen some of this confusion online. Every so often this question pops up on Facebook, Instagram, all over the place. And people get into these huge debates and start calling each other names and all sorts of stuff about which one is correct.
I've got it, sir. I've got it.
Okay, perfect.
Yeah.
And most of it stems from people mixing up the order of operations. So let's go over what these are. The order of operations means the order in which we will work out any type of problem or simplify it. So I'm just trying to move this, sorry. So we start off with parentheses. That's where we begin. So we start here and we work our way down. And so we basically say these are the stronger operations on the top with the weaker ones on the bottom. So we start at parentheses or grouping. Another name for that is quantity. Remember, we saw that in the previous question on page 51, number 5, it spoke about quantity. Quantity is when you group something, such as x plus 5 in parentheses and the 2 on the outside. This one has been grouped as a quantity. So we read this 2 times the quantity x plus 5. So basically, you always start with the parentheses, the groups or the quantities. Right, then you go on, if you're working out something, you do exponents next. So you start off with your exponents. And exponents basically means your powers or your roots. Remember, powers could be like x cubed, and your roots is like the cube root of 5 or something, right? So those are what I mean by powers and roots. Those are what you do next from left to right. And then it's multiplication or division, whichever one comes first from left to right. So if division is first, you do division first. If multiplication is before the division, do multiplication first. And then addition or subtraction, whichever one comes first from left to right. All right, so we're gonna go ahead and do a few of these. Once again, these are not in the book, but they do require you to know it. And technically, this follows you to every single math level that exists, whether it's geometry, trigonometry, calculus, pre-calculus, right? Any math that exists, this follows you. All right, does everyone have it written down?
Yeah.
Yes.
All right. And for some reason, okay, here we go. So I'm gonna try to bring up this question that people love to bring up. And you might have seen it before. You might have been one of the people arguing about it. I don't know. We'll see in a moment. But it's a very popular question, and then my internet decides. Can you guys still hear me?
Yeah, I get it.
Yes, I can hear you.
Okay.
Yes.
We figure it out. All right, so I see it, but this one has the actual. Okay, here we go. So this is like this viral question here. Come on, I can't bring it up. Trying to open this up. Okay, why is it acting up? Okay, so I don't know what's wrong with this thing today. Normally I'll just share it with you so you can see it. Driving me crazy. It looks like Google changed its things. Normally you can put view image and it will blow the image up, but today, for some strange reason, it doesn't want to do that. So I was trying to make it larger for you guys. Can everybody see this question here?
Yes.
Yes, I can see it. I can see
Yes.
it.
I don't know what's wrong. It's like an update has happened here and that option is no longer available. So anyhow, this is the one we're going to try. So go ahead and try to work that out. Do not use a calculator. That would be cheating for now. Try to see if you can get the correct answer. I don't know if you've seen this on social media, people debating about what the answer is. But if you do see it again, it pops up like every year, and you join the discussion, hopefully you can be confident of the right answer.
Is it 6 for the first one?
I mean, what do you mean by the first one?
Wait, you don't want to
Is it 9 times 10?
All right, so what I want you guys to do, just put your answers in the chat. You can put it in privately or you can put it to everyone if you don't mind. But go ahead, put your answers in the chat of what you think the answer is. Okay, so I have some answers popping in already. All right, so I have 1s and 9s, which is literally what people are debating about. So if you find this on social media, you're going to see people saying 1s and you're going to see people saying 9s. And then it's a huge debate and everybody's calling people names. Hopefully, if you've been on there, you haven't called anyone a name, but you try to prove why your answer is. So 1 or 9, that's the answers you should get there. You see a 9 times 10, but it should be 1 or 9. One of those answers are correct. So let's see which one is. We're going to follow the order of operations to do this. And I'm going to try to put it right there in that black part. Okay, so I got more 9s than I did 1s. Hopefully no one used a calculator. No one used a calculator, right? So we have 6. The key is to rewrite it sometimes in a different format. So we have 6 divided by 2. Remember, when a 2 is outside of the parentheses, what does that mean?
Multiplication.
So multiplication, 1 plus 2. So let's go ahead with the order of operations. What do we do first?
We divide 2 from 6.
No, no, no. What do we do first according to the order of operation?
Parentheses.
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 Right, so we're going to do the parentheses first. So we have 1 plus 2 is 3, right? Now, this is really important that you follow the order, because what happens is some people don't follow the order, but just happen to get it right for one question. But then the next questions, they get them completely wrong. Always follow the order until you have it completely mastered and you understand it in and out. So if we were to rewrite this, we have 6 divided by 2 times 3. What would be the next thing to do by the order of operations?
Multiplication.
Multiply.
No, not multiply. Remember, it's
Division or multiplication?
Right, division.
right. It's multiplication or division, whichever one comes first. So which one would we do first here?
Dividing.
Now we can divide, as George has said. 6 divided by 2 is 3, and we have 3 times 3. And what's 3 times 3?
9.
9. And that would be your answer. Your final answer would be 9. All right, any questions with that?
Yes, Mr. Ray. How did they get the 9? I mean, the one, my bad.
Oh, okay. How 1 comes up basically when people multiply. So some people, because of how it's been taught, or how sometimes people don't catch that last part, some people only remember PEMDAS. And so if you only remember it as PEMDAS, you think that multiplication always comes before division. And if you think that, that means you're going to do this. 6 divided by 2 times that. So you're going to have 2 times 3. And you're going to say 6 divided by, you're going to work out your 2 times 3 first, if you think that. And then you say 6 divided by 6 is 1. So the key is to remember that these two are like twins. And let's just say you see twins from afar. You might not even worry about the age. You're just going to say, whichever one of you comes first gets it, right? Don't worry about age.
Mr. Ray, P stands for what?
Say what?
The P symbolize which word? The
You
P.
said D? D is
P.
division.
Ah, okay. The first one, D, is division. Then the next one is we have division.
It's in the.
I just need the abbreviation for all these words that you're written. They have P.
Now this is basically the same thing that I wrote from the PowerPoint. Did you get it from the PowerPoint? George, did you get it from here? This is where I'm calling the stuff out from.
Okay, okay.
You already wrote that down, right?
Yeah, but where do we start first? Is this from addition, subtraction before going to multiplication?
You said, why do we do it first?
Yeah.
That's just observation of life. When you read a question, like when we were reading questions and creating those equations, just what we do first. So like, for instance, let's reshare my screen. And I'm just going to mute everyone. I'm picking up you guys' conversations at home, and multiple ones at that. I'm just going to mute everyone. So I'll give you an example. Let's say you go to the store and they have a sale, buy one, get one half off, right? If you get it at regular or less price value. You guys have seen those sales. So let's say you go to the store and you see a shirt for $38, and then you're shopping around, you see another one for $45, right? How much money would you pay? Well, depending on how you look at the order of operations, some people are going to do this. Now, is that correct? Is that how we actually find it? This is actually incorrect. This is a violation of the order of operations based off of just real life. In real life, what we're going to have to do is we're going to have to find the highest priced first, because based off of how the sale works, it's they take the highest price, so $45, and then you get half off whatever is the lesser value. So that's going to be plus 38 over 2. And so the order in which you do that is really important. But the order of operations is not just something we conjure up. It's something that we see every single day. It's something we observe. And that's what mathematics is. Most people, if you ask them on the street, what is math? They're going to say it's something crazy, it's silly. But no, it's literally why we have all the luxuries we have. It's based off of our observations of how the world works. And so the order in which we do things, after hundreds and thousands of years of studying, we realize that we're going to do it in a specific order and that this actually matches real life situations. And so, no, we don't divide everything there by 2. We're going to have to do it by a specific order. So does that make sense? Hopefully it does. All right, let's try another viral one. I saw it here. This was also a viral one that I've seen on social media. Actually, this one looks like it came from the Telegraph, which is a UK paper. Let's see what answers you guys get for this one. This really, and this is not really algebra. This is just order of operations. I should have done it in Unit 1, but because it wasn't in the book, I actually forgot. So what answer would you get?
Wait, where's it up there, angry? Wait, does it show like a red dot on the bar? Or it's not there?
And remember, you send your answers in the chat. Okay, I got an answer so far. Remember, don't use a calculator. Okay, I got another answer in.
Have you seen mine?
Okay, I got a few answers in here. Let me just answer people.
Is that have you seen my answer?
Yeah, I'm about to write back each person as I have a few answers in here. All right, so about 6 people have sent in answers or so. I have about 20 people in here. So, 6, 20, 10, 10, 19. Thank you, Sal. 19 people in here? 19 people in here, including myself, so that's 18.
I send my my answer. Can you tell me if it's right or wrong?
Okay, who sent that? Who said it?
Norma.
Norma? Yeah, I wrote back to you, Norma. We're ready. Did you see my response? Norma?
Yes, I did. Thank you.
Plus and take away.
All right.
Yes.
Okay, I have a good bit of correct answers coming in.
No, 9 minus 3.
All right, just for time's sake, because I do want to get to solving equations, and it's important that we cover this, I'm going to go ahead and start this one. If I miss your answer while I'm writing, oh, just throw another one. Oh, okay.
So you convert that 1/3 to an upside down.
Okay, so I have a good bit of correct answers. Now, you notice here you have to remember how to do fractions. So if you've forgotten how to do fractions without a calculator, you want to practice that. So we have 9 subtract 3 divided by 1/3 plus 1. All right, so the first thing is you want to start with the stronger operation. And what is the strongest operation if you're doing the order of operations here?
3 divided by 1/3.
3 divided by 1/3. But how did we learn to divide fractions? I gave you a little acronym, KCF.
That is,
Multiply.
you multiply.
We multiply. We keep the first one, change the sign. Let me change the sign to a dot. Change the sign to multiplication, and then flip the second fraction. And 3/1, which is the answer, is the same as simply saying 3. So that means we're going to have here 9 subtract 3 times 3 plus 1. So what do we do first? Well, it's still multiplication because they're like twins. So what's 3 times 3?
Subtraction.
3 times 3 is
9.
9. So we're going to have 9 subtract 9 plus 1. Now, this is where you can also end up, you know, you could do it different ways. With addition and subtraction, the order doesn't really matter, but we typically just try to keep the rule from left to right. So going from left to right, what is 9 subtract 9?
0.
0. And then we have 0 plus 1. And what's 0 plus 1?
1.
1. And if you do that in your calculator, you get the same answer. The answers are programmed that way. All right, so those are 2 viral problems. I've seen these both on social media on different platforms, and I often join in trying to explain to people how to do it because people are debating and calling other names and they're smarter than each other. So, you know, you try to go in there and say, no, this is how the order of operations work. So if you are in those discussions, you can say it now. It's from left to right with multiplication and division, whichever one comes first.
Mr. Ray, on the fraction when we were dividing, when we flipped it to a multiplication, why do we keep the bottom number on the
Well,
fraction?
because 3/1 is still 3, right?
Okay.
Right. Any number, any whole number can be written as a fraction as that number of a 1. So, you know, it's kind of redundant to keep it. You don't really need to keep 5/1. We could just write it as 5. So we don't have to leave it as 3/1. 3/1 is 3. 3 divided by 1 is 3. Now you can keep the frac as 3 times 3/1, but most people get confused when it's time to multiply it. So I just leave it as 3 times 3.
Mr. Ray, let me give my own impression.
Well, the time is running out, and just ask. How about you ask the question? So where did you go wrong?
Yeah, where I go wrong is that I was thinking I'm supposed to take I have to start subtractions and addition first before going to the multiplication and division.
No, remember we're following the order. So parentheses, exponents, multiplication or division, addition or subtraction. So we have to start here. There's no, and this is for everyone. You do not want to put your own stamp on it. You have to do it by the way that we have observed, and that's how we do math. Like I showed with the example of the clothes, right? It's the order of operations there. We can see it, and now we're just making sense of it and writing it up in a rule. So it has to be in the order that I have here. All right, so parentheses first, exponents, which is basically powers and roots, And you shouldn't have, we're not going to have too much of that. Multiplication or division, whichever one comes first from left to right. And then addition or subtraction, which doesn't really matter, but just keep the mindset, whichever one comes first from left to right. But this is the real key. You have to remember with multiplication or division, it's whichever one comes first from left to right. And it has to be in this order. It has to be in that order. Like, don't think anything else. It has to be in that order. I can't stress it enough. Because the correct order determines whether or not you know how to solve equations. Because as you will see, solving equations is basically the opposite. All right, so I shared this worksheet with you guys, and this is what it looks like. We'll do a few of them. I'll do the first one, number 6 with you, but this is also in the remind, and so you want to work on these as well. The order of
I
operation.
didn't get that, Mr. Ray.
Are you in the remind group?
Yeah, but I didn't, for some reason, I didn't get it. I got another one, but I think that was from last
Let me check
session.
to see if it went through then. Who's talking? Was it Dina?
Yeah.
You're right. For some reason, it did not go into your side. That's weird. It's really weird. But everyone else, do you guys see it?
Yes.
Yeah, so that's weird, Dina. I see that you're in the group. You probably see me clicking on it, but yeah, it's not popping up on your side.
I did receive it. I checked on it and I did get it.
So you did get it. All right. It don't make sense. Yeah, it's not showing up on your side. All right, so let me try to reshare that.
Okay.
Did anyone else? Did it not come through for you? Let's see. I'm just going to share it as a file. Let's see if this works. Come on. So, no, that's not going to work. Or is it? Let me see. No, that's not going to work. All right. Let me try it again. Okay, Dina. Okay, tell me if you see it. It looks like you have seen it. Dina? It says you've read it, so I'm gonna take that as a yes.
Yeah, I got it, Mr. Ray.
Okay,
Sorry,
perfect.
I was checking. Yeah, I got it.
All right, so everyone else, you should see that there. And we're gonna do number 6, and then I have you guys try number 7. And I gotta do it a little bit fast because I did want to show you at least one equation. So first of all, order of operations, and you'll see that you can skip steps, but I'm gonna suggest that you don't do it yet. Really work on just following the order, and you will start to see it. All right, so you see here I put slashes, whichever one comes first from left to right. So where do I start here? Well, we start in the parentheses. Now you see there are 2 sets of parentheses on this worksheet. The outer ones don't really need to happen, so we're going to start inside of these parentheses first, the inner parentheses. And then where do I start inside of the parentheses now that we've done the parentheses?
The exponent.
The exponent. So we do 4 squared. So we're going to have 5 squared plus, well, we could do both exponents technically, but you see, it's always best to just do it step by step. So plus 16. Right, we're still working inside the parentheses though. So we're still in here. So what do we do next inside of the parentheses?
Divide.
Right, dividing is the next one. So 14 divided by 2 is 7. 7 plus 16. We're still inside of the parentheses. So what do we do next with the parentheses?
We add 7 plus 16.
Right, 7 plus 16 is going to give us how much?
22.
23.
3.
23.
23, okay. And then now we're outside of the parentheses. So the parentheses are done. And what will be next?
The exponent.
Exponent, which will be 25 plus 23. And then we can add those together. What's 25 plus 23 going to give us?
48.
48. All right, and that's how you would do it with an exponent. Now, like I said, after a while, you start to see little shortcuts that you can do that don't technically violate the order of operations. But to be on the safe side, especially if you're trying to get a test under your belt, you want to make sure you just follow it step by step. All right, I said number 7, but let's try number 2. See what answer you get. Try to do it without a calculator, and then you can do the rest on your own. So number 2, see if you can get that answer. All right, I'm only looking at number 2, so don't check the answers on, well, you technically can. If you really want to see your answers, you can look at the bottom. And just for time's sake, I'm looking at the time. I did really want to try to start an equation today so that on Thursday, we're like almost there. So I see 21, 18, 21, 21, a few 21s and 18. So let's go ahead and do this one. We have here, I'm just going to clear this other one and scroll up so I have more space. So we have 3 squared. Remember, we're going to start, I'm going to have to write this in the middle because my left screen, I don't know what's wrong with it. A good bit of 21s have just come in, and you can scroll down to the bottom to see your answer. We have 3 squared plus, we start inside the parentheses. We have 15 divided by 5 plus 3 squared is 9. And then we have 3 squared plus 15 divided by 5 is going to give us 3.
3 plus 9.
3 plus 9. 3 squared plus 3 plus 9. The 3 plus 9 in the middle is going to give us 12. And then 3 squared is 9. I'm just skipping a few steps. And then 9 plus 12 is going to give us 21. If you got 21,
yeah, I got it.
Correct.
All right.
And I believe they actually show you the steps here. Yeah. So they show the steps in there so you can actually check your work as well as the answer. All right, so that's where we're stopping. That's the order of operations. Really important information. Now with that, this now bridges us back to the equations. When we solve equations, solving an equation, what we're going to do, we're going to backtrack. So imagine if I traveled from, let's say, on here on the 10, let's say from Fontana Adult School to LA, what's that, about 60 something miles? And let's say I took the 10 and 605 in, right? And let's say I have to come back the exact same way. And I'm just going to throw out some numbers here. My numbers may be off. But let's say it's 40 miles on the 10 and 20 miles on 605. If I want to get back to the same place following the same freeways, then what would I have to do? Instead of traveling west and south, I'm now going to have to travel north and then east, right? And then not only do I do this opposite operation, I have to do the same number. So if I went, let's say 40 miles west on 10, and then let's say 20 miles south on 605, then to get back, I need to do 20 miles north on 605, 40 miles east on the 10. Does that make sense?
Yes.
Right? That is literally how we're going to solve. We're going to do the opposite of what we've been doing. Just the same way, if I was traveling back on the road that I went on, I do the same numbers back, but opposite operation or direction. So if I'm doing the opposite direction, instead of starting from the top down in terms of the order, I'm going to start at the bottom and work my way up. Does that make sense?
Yeah.
Yes.
Yes, yes.
Yeses. Thumbs up. Yeses. Does that make sense?
Yes, sir.
Mr. Ray, I think when you do this, let's
Got
do
him, sir.
an example. That's why we need to understand more.
No. First, we really need to get this down. I've been teaching for years. You got to get down this concept or else it just goes over the head. Marisol, you have a question?
No, sorry.
Okay. So once we do that, we're just starting at the weaker operation. That is key. You can write that down. We're starting at the weaker operation. You have to know where to start when you're solving the equation.
No.
You must start at the weaker operation. So the strong one is up top, weaker one is at bottom. And so when you start the process with equations, you will start at the weaker operation. Once you do that, what you do is the opposite operation. And I thought I had an example here. So we're just going to jump right. Actually, we're going to use the book. The book has an example there. And I'm working on time. Like I said, I really wanted to start it. So the book has a perfect example right there on the left. Now, you may not understand it just by glancing at it. So I'm going to do it on the side. And they actually picked a more challenging one, which is kind of good. And so I'm going to pick up here on Thursday. But like I said, I do want to work it out. And remember, where do I start? With the weaker or stronger operation?
Weaker.
Weaker. That is so key. You understand that, you're on your way to do well with algebra. So, using the order of operations, which one is weaker? There are two operations here. When we're solving for x, we're trying to get the x by itself, which means we're basically going to move these other ones to the other side. And the way that we do it, we basically do the opposite operations, but we have to start somewhere. And where will we start? With the weaker operation. And what is the weaker operation according to Pam, to our order of operations?
Adding or subtracting?
Adding and subtracting. So we're going to start here. If you don't start there, you will get it wrong. You have to start with the weaker operation because you're basically backtracking. And remember, with the order of operations, the last thing you would have done would have been to add the 4, which means if you're going to work your way backwards, the first thing you're going to do is start with the +4. Does that make sense?
Yes.
Okay, so now that we know where we're starting, we have to remember also the rules of backtracking. So like I said, if I was coming back from the LA area, instead of doing south.
Mr. Ray, yeah, Mike, I don't know. The volume is too slow.
Can you guys hear me?
You're cutting off, Mr. Ray.
Yeah, you're breaking down, Mr. Ray.
All right, I don't have a sign
You
that my
will.
internet is off. Can you guys hear me now?
Right now, it sounds good.
Yes, it's there now.
Okay, so just try to follow along. Like I said, we're going to pick up here, but I did want to at least start it. So we're going to do the opposite operation, right? So imagine plus is heading east, subtraction is now heading west. But we're heading the same amount of miles, so subtract 4. So we do the opposite operation with the same number. But because this is an equation, what I did to one side of the equation, I will have to now do to the other side of the equation. So we're going to subtract 4 on both sides. What happens? 4 subtract 4 cancels out. And on the left, we are left with x divided by -2. On the right, we have 8 subtract 4, which is just 4. Now there's only one operation left, that's division. And what is the opposite of division?
Multiplication.
So we're going to multiply by the same number. The same way if we went 40 miles south, the way to come back would be 40 miles north. So we're going to multiply by the same number. But because it's an equation, what we do to one side of the equation, we will do to the other. So we multiply the other side by -2 as well. And so that cancels out on the left, and we're left with just x. And 4 times -2 is -8. And there's our answer. Now, if you were to substitute to check your answer as they do here, that's when you would use the regular operations, order of operations, which means you would do this first, -8 divided by -2 to check your answer. You get 4, and then the last step is to add the 4, which you get 8. So if you look at it carefully, all you have done is backtrack the same way you would if you was traveling on a freeway. And we use the same logic that we do traveling on a freeway. Does that make sense?
Yeah.
All right, let's try one more. We got a few minutes to try another one. I'll pick an easier one. I'm just going to make it up. It may end up with a fraction or a decimal. I have no idea. I'm making it up on the spot. So if I had 3x subtract 5 equals to, let's say, 17. In order to do this, I need to first look at my operations. I have a subtraction sign here and a multiplication. So where would I start?
-5.
I'll start with the -5 because I'm doing the order of operations backwards. I'm backtracking. But remember, I'm doing the opposite. So what sign would I do here?
It's addition.
Addition. And I add the same number. I'm doing the same thing, but backwards. So I add 5.
Ricky.
What we're dealing with equations here.
Okay, nada, mijo.
So what we do on one side, I'm
trying to
just
get
going to
one
mute
to
everyone
the
real
store, Nala.
fast here. All right.
Amara.
So what I do to one side, I do to the other side. Over here, the 5s cancel. On the right, 1 plus 5 is 6. There's an equal sign, 3x. Right, so we just bring down what's left over. That's a multiplication, 3 times x. So the opposite of multiplication is division. I must divide with the same number. But because it's an equation, what I do to one side of the equation, I must do to the other. So I divide 6 by 3 as well. And when I cancel over here, I'm left with just x. And 6 divided by 3 is 2. So I've solved that equation, x equals 2. And I can check this. If I substituted 2 back into that equation, 3 times 2 is 6, and 6 subtract 5 is 1. And so that's correct. I'll do one more, and this time I'll use a fraction. Let's say I had x. We had a fraction before. So let's just do one that's a little bit more challenging.
Can you do one more fraction, Mr. Ray? I kind of missed the other one.
All right, I'll do another fraction. So let's say I had an x over 3. And my left side is x over 3 minus, let's say, 5 equals 7. So once again, where do I start?
The weaker part, -5.
-5. I just realized I used 5 again. But anyhow, we have -5. So we start there. And what do we do? The opposite. So what's the opposite of subtracting 5? Adding 5. So we're going to add 5. And what we do to one side, do to the other. All right, those 5s cancel. We have x over 3 is equal to 12. Now we only have one operation left, so we can get to that x, and that's division. So we're going to do the opposite of division, which is multiplication. And what we do to one side, we do to the other. And so we're going to multiply that by 3. And what we do to one side, do to the other. We're left with x is equal to 12 times 3, which is 36. All right, and if you used to check that, 36 divided by 3, the order of operations is 12, and 12 subtract 5 is indeed 7. And this is why you need to know the order of operations so that you can solve, because you're solving by backtracking, just doing the opposite. All right, this is where we'll pick up on Thursday. Just work on those worksheets. I'm going to send a worksheet on solving, so look out for that as well. Just a basic one like this. And then on Thursday, we're going to jump right into the GED style questions that they are asked you about solving. All right, you guys have a safe evening. Be safe out there. Hopefully see everyone on Thursday. And keep practicing, of course.
Okay. Thank you, Mr. Ring.
You're
Thank you,
welcome.
Mr. Ray.
Good
Thank
night.
you.
Good
Good
night.
night.
Have a great
Good
evening.
night. Thank you.
Okay.